Well, once again, ladies and gentlemen, students, good evening and welcome to our class. Arthur Johnson speaking yet again, and going to speak with you this evening on a subject that is dear to my heart, and I hope is one that will interest you too, and that is the history of the telescope. Now, of course, prior to its invention, astronomers did valuable work, but mostly what was possible was to measure the positions of the stars and the planets. But to look deeper and to examine the stars and planets close up required that something be invented, and that something was what we know as the telescope. Nowadays, we speak of telescopes in different flavors. That is, we have optical telescopes, we have radio telescopes, we have X-ray telescopes, we have telescopes that operate in the infrared. But that's 21st century stuff. What I want to talk about this evening all goes back to the year 1608, when a Dutch optician, maker of spectacles, discovered, and maybe it was his kids playing with lenses who really made the discovery. We don't know. But he discovered that if you were to hold up two lenses at suitable distances from each other, one convex and the other concave, it made distant things look closer. His first telescope, as far as we know, had a magnifying power of about 3 times. He began to think that this might be useful for military purposes. That is, if you could see the enemy before he could see you, you were probably in better shape than he was. He applied for a patent in 1608, but he didn't get it. And telescopes, of course, have been used and continue to be used for military purposes. But much more interesting to the story I have to tell you tonight is what was going on in Italy. By the way, this is a recently struck medallion commemorating that Mr. Lippershey was indeed the very first to use a telescope. But as you see, he's looking across the ocean at a distant ship. But in Italy, 1 year later, in 1609, this first telescope. Here's a piece of artwork showing him using it. And here's a painting of him attempting to induce church authorities to look through it. And some of them would, and many of them said, no, it's sinful and we shouldn't look through it. So that's Galileo's getting started with the telescope. The style of optical telescope that Galileo invented we call the refracting telescope. To refract is to bend. And in a refracting telescope, a lens, convex lens, refracts or bends the light of stars or whatever you're looking at and brings that light to a focus at a place called the focal plane. Here's a modern version, a little diagram of a more or less contemporary refracting telescope. In this one, the starlight is entering the tube from the right-hand direction. The lens, the objective lens, brings that light to a focus within the tube, and then a smaller lens at the left-hand side of this diagram is the eyepiece, which allows us to magnify the primary image that the main lens is creating. So this is the telescope that I have at home. There are other types, and we'll speak about them in just a minute, but here is a picture from a museum in Rome, I think, maybe it's Pisa. But anyway, these are literally the first two telescopes of Galileo Galilei, going back to the early 1600s. Now, the lens that refracts starlight is made of glass, of course, and in addition to bringing the light to a focus, it has the character of bringing light that is red in color to a focus in a different place from light that is blue in color. And so looking through these early telescopes, observers were hampered by the fact that the star or the planet or whatever would be encircled by a ring of light of a different color. The stars were sort of rainbow colored, and that did not help a lot. It was discovered after a little while that if you made the lenses almost flat but only slightly curved, this color aberration or this color distortion would be minimized. So fast forward to 1673, something like 60 years later after Galileo's discovery, and there's an astronomer named Hevelius who built a telescope with a tube 150 feet long. It cut down on the color distortion, but boy, good luck trying to aim the thing. Nevertheless, Hevelius used it to good advantage and made what we consider the first really accurate map of the features on the near side of the moon. Well, this chromatic aberration, that's the fancy word for the color variation produced in a lens-type telescope, was addressed by none other than Sir Isaac Newton, and he began to think about bringing starlight to a focus using something other than a glass lens. He wondered if you could make a curved mirror. In his case, he started out with a metallic mirror made of speculum metal. He realized that a mirror would bring all wavelengths of light, all colors of light, to the same focus. And so he built this little telescope in 1668. This is a replica of his very first reflecting telescope. Let's see how it worked. This is a modern one, of course. Looking at the diagram at right, you see that the light from a star enters the telescope, moving from right to left. It strikes the surface of the curved mirror and starts to come to a focus. Now, it wouldn't do us a lot of good to use this telescope unless we used a small diagonal mirror to bounce the converging beam of light off to the side of the tube. Without that mirror, you'd put your head in there to use the eyepiece, and your back of your head would block all the incoming light. So what Newton did was to suspend a small flat mirror to intercept that converging cone of light, bounce it off to the side of the tube where it could be examined with an eyepiece. So this is the essence of the other major kind of optical telescope. This is the reflecting telescope. Contrast that with the refracting telescope of Lippershey and Galileo. Well, using both kinds of telescopes, astronomers began to make discoveries. And one of the things that became obvious was that the bigger the tube was in diameter, the bigger the diameter of the lens or the mirror, the fainter and the more interesting things you could see. So this led to telescopes getting bigger and bigger. Sir William Herschel, the discoverer of the planet Uranus, built this 40-foot long monstrosity in the 1700s and used it not with a great deal of success. It was just too darn bulky. But anyway, both the reflecting and the refracting telescopes started growing. People built bigger ones. And for a long time, it was Galileo's design, the refractor, which got the heavy publicity. Refractors got bigger and bigger and culminated around 1895 or 1900, somewhere in there, with the biggest one ever built. And it is at Williams Bay, Wisconsin, a terrible place to do astronomy because of bad sky conditions, bad weather. But nevertheless, there it was, there it still stands. And this is it, the biggest diameter refracting telescope ever built on Earth. It's got a lens 40 inches, just a little bit over 1 meter in diameter. And it's a huge, big monster. It requires a long tube, very heavy mounting, but it was the culmination of the lens grinder's art. We still use refracting telescopes to this day. Now, how did they get rid of the 150-foot requirement? I neglected to mention this a few minutes ago, but very soon after around 1700, or even a little bit earlier than that, opticians discovered that if instead of a single lens, a convex lens made of one kind of glass. If you complemented it with a second lens that was concave and made of a different kind of glass, they would work together and bring both the red and the blue wavelengths to a focus at a common point. So this is called an achromatic refracting telescope. With such a thing, you could really get good views of the planets and the moon. And the reflector was still stuck because the mirrors were made of speculum metal, which tarnished. And every time the mirror got tarnished, you had to take the darn thing out and repolish it. Very tedious. So the reflecting telescope kind of limped along for a while until in the 1800s it was discovered how to deposit a very, very thin coating of silver onto glass. So that could be done. You didn't have to polish a metal mirror. You could simply re-silver your glass mirror when silver got tarnished. With that advance, with that knowledge, glass mirrored telescopes came on stronger and stronger. In the 1880s, an astronomer in England built what was the world's biggest reflecting telescope at that point. It had a mirror 36 inches in diameter. Then in 1908 on Mount Wilson in Southern California, there was built a 60-inch diameter reflecting telescope, the biggest in the world until all the way up to 1917 when an even bigger one, the 100-inch diameter telescope, was built also on Mount Wilson. Both of these last instruments, by the way, were founded, or funded, I should say, by Andrew Carnegie's foundation. And indeed, the Carnegie Foundation came through yet again about the year I was born, 1949. The 200-inch telescope went into operation in Southern California, not on Mount Wilson, but about 100 miles further south on Mount Palomar. To this day, that telescope is the largest reflecting telescope whose mirror is made of a single piece of glass. If you tried to build a mirror bigger than this, it would sag under its own weight. And that's not too good if you want to bring all the starlight to a focus. I want to digress briefly because as we get to the 1940s, a second very major class of telescope came on the scene, and that was the radio telescope. As you know, stars, galaxies, quasars, pulsars emit energy at all manner of wavelengths other than the optical. The waves longer than optical wavelengths go to the infrared and then to microwave and then to radio wave. And it was discovered in the 1940s that the universe was very interesting to examine in these longer wavelengths. And so although it's not my main focus in tonight's talk, I wanted to just mention to you that radio telescopes came onto the scene and continue to be used all the time. This is the biggest one on the planet. It's the Arecibo radio telescope in Puerto Rico. It's got a spherical mirror about 1,000 feet in diameter. It was constructed in a natural volcanic crater, or actually more like a sinkhole, I believe. But using this telescope, in 1967, the very first pulsar was discovered. That's a star that is spinning on its axis many times per second. Pulsars, as we now know, are neutron stars. They are the remnants of a supernova. And the supernova remnant collapses on itself and is tremendously dense, subject for a talk some other time. But this is the Arecibo radio telescope in Puerto Rico. Here's a better picture of that giant reflecting surface. By the way, it is a sphere and not a parabola, but again, a detail for later. Well, in the last several decades of the 20th century, humans began to dream about getting rid of the problem of the turbulent atmosphere. The stars twinkle, and they're very pretty to see when we look at them naked eye as they're twinkling, but that twinkling tells us that the starlight is being distorted as it comes through Earth's atmosphere. Astronomers were keen to figure out how to get rid of that distortion. So the obvious answer was, one of the obvious answers, was to put a telescope above Earth's atmosphere. And in 1990, the Hubble Space Telescope, which everybody's heard of, was launched, placed in Earth orbit, where it remains today. I don't imagine very many of you have not seen the gallery of amazing pictures that Hubble has given us. Pictures of objects in our own solar system and far beyond. A close-up here of just a portion of the great spiral galaxy in Andromeda. This is the Helix Nebula, one of a number of planetary nebulae, so-called because to early astronomers that disk resembled perhaps the disk of a planet. But what's going on with this one is that the star right in the middle had a nova explosion and blew off a shell of gas, which we can see in the Hubble photo. So the Hubble was a gorgeous instrument. It has pushed our vision of the universe and the details in the universe far beyond what could be done before. The successor to the Hubble, which is somewhat of a boondoggle, way over budget, way late, but it's going to be launched, we are told, next year in 2021. This is the Webb Space Telescope, and it will observe mostly in infrared wavelengths and be able to give us insights into the very, very earliest days of the universe when galaxies were just forming. So watch for that, the Webb Space Telescope, slated to be launched next year. Now about Hubble, it has been serviced by the astronauts back in the days of the shuttle. It is estimated that it will continue to be viable and continue to do useful work for about another 5 years, till about the middle of the 2020s. Now remember, we were interested in getting away from the distortions of Earth's atmosphere. And putting a telescope in Earth orbit was certainly one way to do that. But it turns out there are other ways to solve the problem of the atmosphere's turbulence. This is one of the twin telescopes on Mauna Kea in the Hawaiian Islands. It's called the Keck Observatory. There are two of them, identical telescopes whose diameter is about 3 times the diameter of the 200-inch, enormous instruments. And they observe through a lot less atmosphere, since they're located 13,000 and change feet above sea level. So already they are doing away with the distortions of a great deal of the Earth's atmosphere. But another very important point is that starting in the 1980s, astronomers, well, actually opticians who were working for the Department of Defense, discovered that there were very clever ways of using flexible mirrors and changing their shapes thousands of times per second to eliminate a great deal of the distortion caused by atmospheric turbulence. This was actually a classified technology that was invented by the United States, and the idea was to be able to spy on Soviet-launched satellites and see what they were. So the idea of a flexible mirror to correct the incoming wavelength or wavefronts of light was a cultural artifact of the Cold War. But in about 1988 or thereabouts, the technology became declassified, and suddenly research astronomers were able to use adaptive optics. That's the generic term for the deformation of a mirror to correct out the turbulence of Earth's atmosphere and allow very, very fine details to be seen in distant stars, planets, galaxies. So there they are. I've been to this mountaintop. It's way high. You don't want to go jogging around the parking lot at 13,000 feet. But there they are, the twin telescopes of the Keck Observatory, and very rightfully they claim that they are the portal to the universe. So we have adaptive optics now being used at major observatories on Earth's surface. We have the Hubble Space Telescope, which is in Earth orbit, going to keep working, we hope, for another 4 or 5 years. And then on the left-hand part of this panel, the James Webb Space Telescope, which is the telescope that your children and grandchildren will hear about as it makes further discoveries about our amazing universe. With that, my presentation comes to an end for tonight, and I will be going live again to take your questions and comments if you have them. So thank you very much. Arthur Johnson speaking.